In this video, we're going to answer all of the fill-in-the-blank questions from Chapter 2, Functions and Relations. At the end of each of the 8 sections, there's a group of fill-in-the-blank questions. I pulled all of those questions and mixed everything up, so we're going to answer them in just a random order. So this should be helpful for you to review all of the topics and cement a lot of the things that we talked about. So let's get started. A graph of an equation is symmetric with respect to the blank axis if replacing y by minus y results in an equivalent equation. Okay, this is going to be the x-axis. And why is this? Because we talked about in transformations of graphs, if you replace y by minus y, or in the same way you put a minus 1 in front of all the y's, you're flipping that equation about the x-axis. Well, when it comes to symmetry, if you do that for an equation, simplify and get the same equation back, then the graph or the equation is symmetric with respect to the x-axis. The midpoint of the line segment with endpoints x1, y1, and x2, y2 is given by the formula. Okay, so this is x1 plus x2 divided by 2. That's the x-coordinate. And then y1 plus y2 divided by 2. That's the y-coordinate. An even function is symmetric with respect to the what? Well, okay, remember, there's only 3 forms of symmetry. At least we're just talking about in 2D. In 2D, and then we're talking about the Cartesian coordinate system as well. Symmetric with respect to the y-axis, symmetric with respect to the x-axis, and symmetric with respect to the origin. Now, if you restrict that to just functions, then you're also restricting the potential forms of symmetry, because a function, a function can't be symmetric with respect to the x-axis, because then it wouldn't be a function, right? Unless it's the trivial case where f of x is equal to 0. So there's only 2 potential forms of symmetry for a function: symmetric with respect to the y-axis, symmetric with respect to the origin. If symmetric with respect to the y-axis, it's called an even function. Right, like this. That's a function, right? It passes the vertical line test. It's symmetric with respect to the y-axis. A blank to an equation in the variables x and y is an ordered pair xy that makes the equation a true statement. This is a solution. The x and y axes divide the coordinate plane into 4 regions called what? Quadrants. The first, second, third, and fourth quadrants. Given f of x is equal to x plus 1 over x plus 5, the domain is restricted so that what? X can't equal minus 5. This is a rational expression, or a rational function, which is a ratio of polynomials. Polynomials have the domain is any real number, but because we have a denominator here, we can't divide by 0. So the only restriction is where this polynomial here is equal to 0. That would be when x is equal to minus 5. The function f divided by g is defined by f divided by g of x is equal to, so just f of x over g of x. Provided that g of x is not equal to 0. Right? You can do any kind of algebra of functions you want, but if you do something like dividing by a function or taking the square root or an even root of a function, then you have to apply, you have to restrict that function to where, like here, g can't equal 0, or if you had, then g needs to be greater than or equal to 0. The y-intercept of a graph has an x-coordinate of 0. The y-intercept, where does the graph intercept the y-axis? Where does it intercept the y-axis? That's when x is equal to 0. A graph of an equation is symmetric with respect to the blank if replacing x by minus x and y by minus y results in an equivalent equation. To the origin. Okay, so If we replace x by minus x, we flip about the y, but look, we're not on the graph, so it's not symmetric with respect to the y-axis. If we flip x by minus x, or no, yeah, x by minus x, we go here. If we flip y by, or we switch y with minus y, we come here. Look, we're not on the graph. It's not symmetric with respect to the x-axis. But if we flip x by minus x and also y by minus y, we're on the graph. That's symmetry with respect to the origin. A blank equation in the variables x and y can be written in the form ax plus by is equal to c, where a and b are not both 0. This is a linear equation. Right? This is it's the standard form. It's called the standard form. I wish they would have called this the general form. This is more like the general form to me. The general form of any equation we're going to see is so like y is equal to mx plus b. That's the slope-intercept form. That's kind of like a standard form based on the way they use the term, because you can look at this and pick off the slope and the y-intercept. Like with the equation of a circle, this is the standard form. You can read off the radius, read off the center. The general form is when you just expand everything, combine like terms, and just bring everything to one side. It's just pretty much everything's expanded. You can't read any descriptive information off of the equation, right? The standard form of a circle is like ax plus by plus c is equal to 0, right? It's just everything's expanded out and just grouped together on one side. You can't read any information off about this. That's what's typically called the general form, but for some reason they call this the standard form for a line. But yeah, so it's this form, and the only restriction you can have the a, b, and c can be any real number. You just can't have both of these be equal to 0. If that requirement is met, then you're going to have a line, and the graph is going to be a line, either vertical, horizontal, or slanted. Given an equation in the variables x and y, find the y-intercept by substituting 0 for x and solving for y. Right? Because the y-intercept, where the graph intercepts the y-axis, x is going to be equal to 0. So if you set x equal to 0 and solve for y, that's going to be a y-intercept. The slope of a horizontal line is what? And the slope of a vertical line is, so the slope of a horizontal line is going to be equal to 0. The slope of a vertical line is technically undefined, but if you want to think about this conceptually, you could say that it's infinity. That's technically not the correct answer from a math standpoint, but from a conceptual standpoint, it's like infinity. Right? If you have a line here, a vertical line, and you have a vertical line and you just barely tilt it. I mean, by like a thousandth of a degree. Then what does that mean? That means you go just a sliver in the x and then a large amount in the y to get back to the line. So that's delta y divided by delta x is a large number divided by a very small number. You're approaching infinity. But technically, you can't divide by 0, so it's technically undefined, the slope of a vertical line. The graph of a constant function defined by f of x is equal to b is what? A horizontal or vertical line. Okay, this is a horizontal line. Why is that? F of x is equal to b. For any x value you put in, the output is b. That's a horizontal line. This x, output b. This x, output b. This x, output b. A graph of an equation is symmetric with respect to the blank axis if replacing x by minus x results in an equivalent equation. Y-axis. If you put a minus 1 in front of the x in an equation, you flip about the y-axis. So if you do that and you simplify the equation and get the original equation back, that means the graph is symmetric with respect to the y-axis. Given g of x is equal to the square root of x minus 5, the domain is restricted so that, well, you can't divide by, you can't take the square root of a negative number, right? You can take the square root of 0, though, so the domain is restricted so that what? Okay, we need to solve when is x minus 5 greater than or equal to 0. That's the allowable domain. So let's solve this inequality. So there you go. X can only be greater than or equal to 5 for this. A function f is a linear function if what? Okay, so a function. So we saw the standard form for the equation of a line is this. But that's not a function because it's not. It needs to be have something as a function. You want to write it to where it's like y is equal to something. It's like a machine. Like you put an input, you get an output. Here, yeah, I could put an x, but then I have to solve for y to get the y. So it's technically not in function notation. You want to solve for y. If you solve this for y, you get the slope-intercept form. mx plus b. Y is equal to mx plus b. And since this expression is a function, you can replace y with f of x, where m represents the slope and 0b represents the y-intercept. Exactly. If f is defined on the interval x1, x2, then the average rate of change of f on the interval x1, x2 is given by the formula. Okay, the average rate of change. We talked about this. The average rate of change over an interval. So you start here, you end here. You can do all kind of crazy stuff in between the 2 points, but in general, the idea is the average rate of change, you just take y2 minus y1 and divide that by x2 minus x1. It's the slope of the line between those 2 points is the average rate of change. And it was assuming that you couldn't do this. You couldn't have something like this and then come down here like a piecewise type function or jump discontinuity. You're assuming it's an unbroken curve. Then in that case, the average rate of change is the slope of the line between those 2 points. The composition of f and g denoted by f, this notation, is defined by, so the way you read this notation is f of g of x. So f of g of x, like that. Given a function defined by y is equal to f of x, the statement f of 2 is equal to 4 is equivalent to what ordered pair? Okay, ordered pair. In other words, you can graph this. You have an input 2 and an output 4. Right? This is a relation. You input an x, you get output of 4. But it doesn't have to be a function. It could be anything, any equation with 2 or more variables. But we think in 2 variables just for the sake of analysis. But you input an x, you can solve for y. Input a y, solve for x. You can get ordered pairs that you can plot. An x-intercept of a graph has a y-coordinate of 0. X-intercept. Where does the graph intercept the x-axis? If it's intercepting the x-axis, the y-coordinate has to be 0. Given a function defined by y is equal to f of x, to find the what intercept, evaluate f of 0. Well, what are you doing here? You're setting x equal to 0. That's the y-intercept. If m1 and m2 represent the slopes of 2 non-vertical perpendicular lines, then m1, m2 is equal to... Okay, so what do we know about non-vertical perpendicular lines? The reason why they're specifying this is because, remember, you can't have... There's no slope of a vertical line. So as long as they're non-vertical, you can think about multiplying the slopes of the 2 lines. Okay, well, what do we know about how is the slope of a line and then of one line and then a line that's perpendicular to it? How are those slopes related to each other? M1 is equal to minus 1 over M2. So if you multiply this entire equation by M2, what do you get? M1, M2 is equal to minus 1. Given a function defined by y is equal to f of x, to find the x-intercepts, substitute 0 for f of x. F of x, remember, yeah, f of x is like equal to y. You have y is equal to some expression of x. So it's the same idea. You substitute f of x for 0. Because f of x is the same thing as y. It's just you're using function notation for the case of a function if you want to. So replace f of x with 0 and solve for x. And you get the y-intercepts or the x-intercepts, because you're substituting y for 0, or 0 for y. Consider a relation that defines a time y during the course of a year when the temperature T in Fort Collins, Colorado is 70 degrees Celsius. Does this relation define y as a function of T? Explain. Okay. Consider a relation that defines a time y during the course of a year where the temperature T in Fort Celsius, Colorado is 70 degrees. Okay, that's interesting. So, can you say y of T? This is you input, the considered relation defines a time y during the course of a year when the temperature T. Okay, so the idea is it's inputting a temperature. Okay, so you've got temperature on the x-axis and time on the y-axis, but it's only going to have an output. It's only going to have an output. You can have it'll be recording all kinds of temperatures throughout the course of the year, but it's only going to have an output when the temperature is equal to 70. So you can think about it like this is only going to have a bunch of points on this vertical line. It won't be a continuous line. It'll just be point here, point here, point here, point here, point here. This is just these are just times. I guess it wouldn't go it wouldn't be in the negative range. You can have negative times, so it would just be the range would just be above 0, a bunch of different times. Well, that's not a function, right? It doesn't pass the vertical line test, so you can't do this. Well, you can't write this as a function. An equation of the form x is equal to k, where k is a constant, represents the graph of this is a vertical line. Right? X is equal to a constant. What does that mean? That means it's any point that has x coordinate equal to k. So if this is 3, then it's 3 and then whatever point you want. If k is equal to 3, then it's 3y. Any point y that has x coordinate 3, and that's a vertical line. The distance between two distinct points, x1, y1, and x2, y2, is given by the formula, the distance formula. The distance formula in a Cartesian coordinate system is what? x2 minus x1 squared plus y2 minus y1 squared. An odd function is symmetric with respect to so an odd function, we talked about this earlier. Functions there's 3 forms of symmetry in the Cartesian coordinate system in a plane. Symmetric with respect to the x, y, and origin, but functions by definition are restricted to just having symmetry either with respect to the y-axis or with respect to the origin. There is the trivial case where f of x is equal to 0, where it's symmetric with respect to the x-axis, but in general, functions are only symmetric with respect to the y-axis or the origin. A function that's symmetric with respect to the y-axis is called an even function. A function that's symmetric with respect to the origin is called an odd function. An equation of the form y is equal to k, where k is a constant, represents the graph of a horizontal line. Right? Horizontal line. For any x value, the y value is equal to that constant. So if the constant is 3, then it's any x, 3. That's a horizontal line. The function f plus g is defined by f plus g of x is equal to f of x plus g of x. For algebra of functions, you can put anything you want. Like the notation is you do whatever you want. F squared plus m to the 2/3 minus h over f of x. That is what that means is f of x squared plus m of x to the 2/3 power minus h of x divided by f of x. And then and also you could even do function composition as well. You could say plus m of h. So that's f of x squared plus m of x to the 2/3 minus h of x divided by f of x plus m of h of x. That's what you're doing. The domain it's the intersection of all of these functions. If any one of these functions, if an input x is outside the domain of any one of these functions, then you can't evaluate this. But then it's also, you got to look at, okay, the intersection of all these functions domains, okay, but then also f of x can't be equal to 0, and m of x, well, there's no restriction because it's to the 2/3, but if this was to an even root, then m of x must be greater than or equal to 0. That's how you evaluate the domain. Well, then also you'd have to look at the domain of a composition of functions. That's where the domain of h of x, okay, we already talked about that, but then all of the outputs, the range of h of x needs to be within the domain of m of x, because you've got m of h of x. Write the formula for the slope of a line between two distinct points. Okay, the slope formula is delta y divided by delta x, which is y2 minus y1 divided by x2 minus x1. Suppose that y is equal to c of x represents the cost to produce x items, and that y is equal to r of x represents the revenue for selling x items. The profit of producing and selling x items is defined by the revenue function minus the cost function. They're just giving you a practical example here of doing algebra of functions. Because the idea is to give it, with algebra of functions and composition of functions, you're thinking about, you've created some more permanent functions in your job or for the application, and you're thinking about combining them with algebra, or having like the input of one be the output of the other. Given a point x1, y1 on a line with slope m, the point slope formula is given by, okay, so we know the standard form of a line. We talked about the slope intercept form of a line. The point slope form of a line is y minus y1 is equal to m times x minus x1. Right? You have a point and the slope. You can make the equation of a line like this. If two non-vertical lines have the same slope but different y-intercepts, then the lines are what? Okay, the same slope but different y-intercepts, right? The y-intercepts are different. They're parallel lines. That's the definition of a parallel line, at least in a plane. But you can think about that outside of a plane as well. It's the same kind of concept. In a rectangular coordinate system, the point where the x and y axes meet is called that's the origin. Consider a relation that defines the height y of a tree for a given time t after it is planted. Does this relation define y as a function of t? Explain. So the height y for a tree as a function of the time t after it was planted. So t y. Okay, so the idea is the tree ever going to shrink? Well, no. I mean, I guess that's a good assumption to say in general it's not going to shrink. So you're always, as time progresses, you're always going to be a little bit taller than the previous point. Well, first of all, okay, one thing is you can think of, you can't go backwards in time. Time doesn't stop. So you're not going to have 2 points. Well, okay, no. All right, let's start over here. Okay, yeah, time doesn't go backwards or stop. So, okay, you come here. You go a little bit further in time, it gets taller. Okay, maybe it didn't grow between 2 times. Okay, it's still a function. Even if it shrunk, it would still be a function. So yeah, this is going to be a function. I mean, the only way it wouldn't be, how could you possibly have 2 points at the same time, 2 heights at the same time? You can't. So this is a function, even if it would, the tree would shrink. A set of ordered pairs x, y is called a blank in x and y, a relation. And it's not just ordered pairs, it's any input that's mapped to an output. Right? So even if you had multiple inputs and multiple outputs, it's some mapping from an input to an output as a relation. That's a relation. The set of x values in the relation is called the domain of the relation. The set of y the set of y values is called the range of the relation. The outputs are the range, the inputs are the domain. Like even if you had, like if for equation of 3 variables, the domain is all the set of, or I guess you could look at it as a plane. Whatever this will represent a plane, the set of x's and y's, that entire plane is the domain. And then the entire, I guess, number line here is the range. Let h represent a positive real number. Given a function defined by y is equal to f of x, the difference quotient is defined by, so yeah, we didn't talk about this. We're skipping this one. The expression blank represents that greatest integer less than or equal to x. So yeah, this is just, remember there's a bunch of different functions out there. So like if you wanted to, you could do this. You could say I've got y squared minus square root of x plus the greatest integer function of x is equal to 3. That's valid. It just seems weird because you're not used to this. So if you put this is just, okay, if you input 7.9, output 7. If you just like a root, if you input 4, output 2. If you input 9, output 3. Here, if you input 8.1, output 8. If you input minus 7.2, output minus 8. If you input 3, output 3.